Okay, now, yes, question.
I've been using time of use billing for 17 years, and I've saved about $2,500. I'm ready to put in a photovoltaic system, but they told me that I could not allow time of use billing on a photovoltaic system. Why not, and when would you be able to do that?
The question is, why are we not seeing time of use billing with photovoltaics? And the answer is, it's a technology limitation, that the type of meter required to do net metering and time of use is quite expensive. It does exist, and we are actively pursuing finding those meters. Right now, it's not a cost-effective solution. So we do allow net metering or time of use billing. So we keep paying attention to what we're doing with our meters. Once we get the ERTs and find the meters that'll support doing that, it's in our interest to do it. Installers are critical. When you call us and say, how big should my system be, how much is it going to cost, it requires a personal relationship with a good installation company. Because of the factors, your behavior, the cost and quality, they are, if you go to our webpage and see the list of installers, if they're on there, that means we trust them. And they have experience with our process, and they know what they're doing. So if you're going to do a system, we recommend 2 or 3 contractors. Contact them and ask them for some support. Okay, and I want to say this is a critical thing. Don't put renewable energy on an inefficient house. The first thing you need to do is become efficient. Learn what you're spending. Learn the miles to gallon of your home. Everybody knows the miles to gallon of your car. And we're very sensitive to the price of gas. And everybody, I could ask you to raise your hand, everybody knows it. But you don't know your miles to gallon of your house. Okay? The first thing you should do is get rid of your junky old refrigerator in the garage. And then do a renewable energy project. Okay. That's all I have. Questions now, Bruce? Or?
I'm going to ask that we hold the questions till the other 2 people talk to make sure we get to hear all 3 speakers, and some of the questions are going to be covered by the other speakers. So thank you, Mark. That was a great presentation. Let's have Catherine speak, and then we'll have Kevin speak, and then we'll take questions to make sure that we get everybody a chance to talk. Thanks.
Good morning, everybody. It's great to be here and to be in sunny southern Arizona. It's really, it couldn't be easier to imagine that we could be harvesting all the wonderful sunshine that we have shining on our buildings every day to generate electricity. But it has not been easy to accomplish. You want to go ahead? We're going to be, I have control. And a woman always wants control, right? Okay. All right, I'm talking about photovoltaics or solar electric. The systems are, in fact, very simple. How many of you have actually not even seen one of these systems yet? Anybody out there? Okay, it's so simple. Essentially, we have panels that are going to be located up on your roof. When the sun strikes those panels, and if you want to have a further definition of this, we can talk about it at the booth. But the sun, photon energy, actually moves electrons from one molecule to another. The movement of electrons, we know, is electricity. And then the electricity that comes off of those panels is actually DC, or direct current. We're required to put in some sort of electronic piece of equipment that we refer to as an inverter that turns that DC electricity into AC, or house power. And then the reason why we have to deal with TEP is that we essentially feed that power out of that inverter directly into your load center. So there'll be a circuit breaker in there. There's one that says range. There's one that says your pool or spa or your air conditioner. When you put in a photovoltaic system, there'll be one in there that'll say photovoltaic system. So when the sun is shining, you're producing electricity that's going into your home. And essentially what this does is slows down the revenue meter from TEP. So the TEP power is coming in this way, you're producing your power, it's coming here, your house is taking that power in, you're going to use your solar power first. Then whatever you need in excess is going to come from TEP. Now what happens if you're producing more power than you need in any one moment? Your meter goes backwards. And we all should be proud that we live in a utility that was one of the first in the state to have a true net metering program. So as you're producing more power, and you're not on time of day rates, I want to mention that. If you have a traditional rate structure and you're producing more power from your roof or from your photovoltaic system than you're needing at any one moment, your meter will essentially go backwards. And you will accrue those credits at retail. I'll repeat that. You'll be able to accrue those credits for the excess power that you're producing at retail. So that when you need that extra power that night, when the sun's gone down and you've got your television or your lights on, or whether or not you have a system sized big enough that you're allowed to carry those credits month to month to month, so that they can essentially offset the operation of your air conditioner in the summertime. You get those credits at full retail as long as it's offsetting the power that you would already use. A part of the new program that TEP is having with the net metering evolution that's going to be brought down by the Corporation Commission, you can, if you wish, essentially once a year, I believe it's once a year, Mark, get a check from TEP. But the sad news is that if you produce more power than you ever would normally use, then they're only going to pay you wholesale. So that's why when Kevin or I or any of the providers of the photovoltaic systems, when we come out to your homes, we're going to ask you to have your utility bills available. Those of you that have internet access, you can go out to the TEP.com website. You can type in your address and give them your meter number, which is on your utility bill, and you can actually pull off the last 2 years of your bills if you don't actually keep them yourself. But what we want to do is design these systems so that they can be as close to zero on the energy use portion as possible, or based on whatever your budgetary constraints are. There are times, though, when we have to look at and we are constrained by your roof areas, shading, and the like. But that's why you want to make sure that you get a professional coming out to look at your system and to look at your bill and to be able to give you the exact information that you need. I've got a couple of pictures I'm going to go through here and then cover some points. Of course, this is the kind of site that Kevin and I would come out and go, oh yeah, this is great. The house is oriented correctly. We can put the panels right directly on the edge of the roof there. And you can see they fit pretty much in the landscape. That Palo Verde tree, I'm a real environmentalist, I swear. But sometimes we have to say part of that tree is going to have to go at some point. This is an instance where we didn't have a lot of roof space. And so you can see that we can essentially stack panels up and take up large areas to make sure that we can maximize the amount of the roof. You do recall that all of these panels are up on an angle. Tucson Electric Power's requirements to assure that we as consumers are getting a good value and understand what we're going to be getting when our panels are installed, as well as for Tucson Electric Power getting the best bang for their buck that they're paying us, have some specific requirements as far as orientation and angle. An angle just sort of roughly between 20 and 32 degrees, so you're going to see the panels that are kicked up, and they're also going to be wanting us to be within 20 degrees of true south. So keeping in mind, these are some of the issues that we have to deal with. This is a home, this is actually not this is up in Maricopa County, but in this case we had two different roof angles. And so in this case, we could take advantage of almost a flush mount installation and have two different inverters, because each inverter needs to see, all the panels that are attached to each inverter need to see the same sun. So we were able to provide what the customer was looking for by providing multiple inverters. Here's an orientation. All of our houses don't always head south. And so what we had to do in this case was this is where the roof line is essentially going north and south. To have the panels facing south, we had to locate them like this. You notice that we have to keep sufficient space between the panels, between the rows, to ensure that we don't get shading. Because remember that our sun angle drops about 15 degrees from where it is during the equinox. And so we've got to make sure that, because any amount of shading on these panels is effectively going to reduce the system output. The systems I've talked about, we've shown here, some of them are large. This is a small system that we actually installed this week out in Cochise County. But because their utility use is rather low, this is going to cut their electric bill out there in half.